So obviously this has advantage to this, right? Good. But this has this incredible limitation in terms of, first of all, it's not resizable. 100 is 100, right? So if you need 200 integers, but you already have something stored in this array of 100, you're gonna have to worry about copying data over. So that's an additional hassle. If you somehow manage to create bigger array, you still need to move elements, and it's a little hard. The next thing which is difficult is this. If I want to have size specified by the user, right? So int size, and I want the user to specify the size, right? So I'm pretending that the user entered this number. No, you cannot do this. It's not flexible enough to accept variable size. You need to provide a constant size. So this is a terrible limitation, right? If the user is going to decide how many integers they want, then it's the alternative then is, of course, to allocate dynamic memory. But this is more headache. And this time you need to say int my array, right? Something like this, maybe a pointer. Int pointer named my array, and say equals new int, and basically say free store, give me a block of integers, and this is how many I need. So, but new is going to be slower. New is going to also be error prone because you can create memory leaks and problems like that. So what you really need is a container which would be flexible, which you can grow and shrink and access in a very similar manner that you could access array of integers. So here it is. You just say std vector, and vector is a template class that it needs to be parameterized by the type that you want to store in this vector. So in my case, I want to store integers, right? And so I will name it my vector, right, as opposed to my array, my vector. And so this is all I created, right? So I just create my vector, and this is the type of object, and this is how it's specified. Then I can, unfortunately, in the current standard of the compiler that we're using, there is no way to specify something like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is not part of the standard to which we confirm today with this Visual Studio 2010. But Visual Studio 2013, which is confirmed with the latest C++ standard, actually introduces way to, there's a new syntax that you can provide initializer for your objects. So anyway, so this is not available, so this becomes an inconvenience at this point. However, it's very easy to populate it by basically saying a vector, add something, and to add something there is a pushback. One of the functions that you can use is pushback, 1, 2, 3, element 1, 2, 3, pushback 1, 2, 3, 4, 5, 6, and so forth, right? 7, 8, 9, and you can add numbers to your vector. And interestingly, just like what you could do with your array, you could say, element number 5 should equal 555. Similarly, right here, I can do exactly the same thing. My vector, element 5, whatever that index is, obviously 0, 1, 2, 3, 4, 5 is like the 6th really element of vector, and it will support the same syntax because the subscript is an overloaded operator in C++, and so it is overloaded for a vector, and it behaves very similar to the way array behaves. So, but look, here's an enormous advantage. Well, first of all, I can actually create a vector of a specific size that's flexible. As opposed to create it blank, I can say this is how much element I wanted to create immediately, like allocate this size and create it for me. Number one. Number two, you can also say that that way you don't even have to push back anything. You can just use element 0 equals this, and then element element 1 should equal this, right? So you just basically use array-like notation because you already created all these elements, and you just use a simple assignment to these elements if you want to assign a specific number there. So again, very much like array behavior, very convenient. At the same time, you just need to remember what type of object you want. So later on, I may want to do something like this, an array of strings. Right? So I may want to create an array of strings. And also this size or some other size, maybe twice this size, something like that. So of course I need to perhaps include this also. String. Right? So include string, include vector, and guess what? It's not a problem. You can create an array of strings, and that's very simple, and something like this will work as well. I just need to name it somehow different, like I don't know, str vector, like vector of strings, right? So here I can say, same thing, element number 1 equals hello or something, right? So you can do this with arrays or dynamically allocated memory. It's very primitive, right? This thing here really doesn't know anything about objects or things that can be done with classes and user-defined types, right? So, so you can do all this, but you have to write your own classes. But look, all of this just fits together so well, right? And you just start using it as in an array-like manner, and it all works. So extremely convenient, right? So in this case, we create a vector of this size. It just creates a vector of empty strings, an array of empty strings. But an enormous advantage to doing something like this manually is that recall that you have to delete things. Someplace you need to say, remember to say delete in your constructor or I mean in your destructor someplace if you're doing it with objects, but you need to say delete my array, and that's how you're supposed to work with new and delete. They're supposed to match. This is on your shoulders. It can be very non-trivial. With vectors, everything is taken care for. You never had to say new to populate something, this size or create individual elements, as we did originally, saying push back this, push back that. Everything, all news and deletes are managed for you by vector itself, perfectly safe, and it just becomes, it really is so widespread in terms of use. It's just almost like part of the language, right? We probably should have been using it a long time ago, but okay, we're starting using it now. So this is some of my thinking along these lines with, like, those vectors and what you can do with them. But let's run some of these demonstrations that we mentioned earlier. So let's save this.